All right, so next up, we have a talk from WEHI about their new, oh, did I turn on audio sharing? Hold on. Well, we're gonna see. Their tool for directly generating MIBI data from an H&E image. Okay, I did not. 1 second.
Scope so far at the WEHI. This presentation today is going to be about the graphical user interface that we've created to facilitate selection of FOVs on the MIBI. This is really some work that's been done by Kenta, Yokote in my lab, and we're going to tag team today is going to give you the second half of the presentation. So we know that cancer is dependent, cancer evolution is dependent on the tumor microenvironment and how that tumor microenvironment influences tumor behavior. And that is really what we're interested in studying in my lab. We're particularly interested in understanding how the immune pressure can activate immunoediting. And we study this in the context of lung cancer and specifically non-small cell lung cancer. So what we're interested in is understanding how, where, and when does immune escape occur in non-small cell lung cancer. And so to address those questions, we work with human samples. And we've decided to evaluate the evolution of the tumor and the tumor microenvironment using different approaches. We're using spatial proteomic with the MIBIscope, spatial transcriptomic with the nanostring geomics, and we're also working on doing some laser capture microdissection so that we could explore DNA, somatic mutation, and other genomic alteration. And the idea is to combine all of these data to better understand tumor evolution and immune escape mechanism. So we have a cohort of non-small cell lung cancer samples that we've been collecting in my lab over the years. And for each of those, we have FFPE blocks. We have survival data as well, and some clinical information. So we have those H&E sections from those patients, and we want to really combine with this the spatial proteomic and spatial transcriptomic. So the big hurdle that we faced when we wanted to start with the proteomic side of things was how could we correlate the annotation that the pathologist did for us on the H&E section, how could we find those regions of interest in the gold slides? And that's where really Kenta developed this graphical user interface to facilitate this interaction. I'm going to now hand over to Kenta, who's going to take over.
Hello, everyone. So I'll be talking about the GUI that I've created to transfer the annotations the pathologist has made on the reference image to the optical image. So what you will need to run the GUI is, I'll go through these one by one, but an annotated reference image and the optical image, the optical coordinates and the SCD coordinates, the MIBI tracker DAT file, and Anaconda 3 or Miniconda to run and install the H&E GUI that I've created. So the annotated reference image is, as we've discussed, the H&E image with the annotations of where you want to scan. And this can be created in any image viewing software. It could be created in ImageJ, Case Viewer, QPath, as long as the annotation box is in yellow. And another thing is that you can make the size, it doesn't have to be one FOV in size. It can be, so what the H&E GUI does is it tiles several FOVs to make one big FOV. So you could have the annotation to be 3 FOVs wide and 3 FOVs down, or however wide and however high you want the total image to be at the end. The coordinates of the fiducial points. So you can read this off MIBI control when you load in the gold slide into the MIBIscope. This is just needed to convert the coordinates we get from the alignment to the stage space so that the MIBIscope scans the correct positions. We usually select 3 fiducial points just to be sure that all the alignments are correct. The MIBI tracker login. So we use a .dat file. This probably isn't the best way to do it, but it is a file that contains your MIBI tracker login details, so your email and your password, and also the MIBI tracker backend URL. And this is just needed to retrieve some metadata for the patients and the images. And finally, we need Anaconda or Miniconda to install. And so you would, after you've installed that, you would just run conda, conda m create, whatever you want to call it. And previously to this, you need to clone the GitHub repository. But all of this information is on the GitHub Wiki. So if you have any questions, it should be there. The answer should be there. So now I will show you a live demonstration. So now I will be going through the live demonstration. I'm going to assume that you've installed Anaconda and have cloned the GitHub repository. So I will now activate the environment and run the script. And this GUI will show up. We have a file naming convention, which we like to use for all of our MIBI scans. So we type in MIBI, the initial of the person who scanned it, and the year in which it was scanned. The slide number is the order in which the slides were, the label of the slides. So in this case, we're doing slide number 7. So we'll type 7 here. The MIBI tracker ID is the ID column that you get in the MIBI tracker. So here, the ID column, and we're interested in slide 7 and number 28. So we'll type in 28 here. And for the FOV size, you can choose between 400 and 800. We'll be choosing 400 for this demonstration. So selecting the optical image. So that is the gold slide image, which is this one here. And then this H&E image, which has been annotated. And again, I'll just go to that. And the DAT file, as I've explained, is the file which contains the MIBI tracker backend URL, your username and password. So I will go ahead and select that. And the output folder is just the folder you want the file to be, the JSON file to be outputted to. So again, I'll choose that. And here, so if I go to my H&E annotation image, I will have the patient labels, or you may not have them, but the MIBI will scan in order of the top left. So whatever is the topmost and then the leftmost. So you will enter the patient name into here exactly as it appears on MIBI tracker. So here I will type in 15MH0358. And then this one is slightly above this annotation. So I'll type in 15MH. So now that I've entered all the patient names, now I will enter the optical coordinates and the SCD coordinates that I got from MIBI control. Cool. So now that I've entered all the optical coordinates and the SCD coordinates, now I can go ahead and align the optical and the HNE annotated image. So to do that, we first need to place landmarks on each of the images to assist in the alignment. So here, we select a few points. So to place a point, we click this add button and we choose some features which can help us align. So the points must be the corresponding points must be placed in the same order. So 1, 2, 3. And then I can place more points to help with the alignment. And so for the sake of this, here I'll place a few more just to be sure. Yeah. Cool. So now that you have all your points placed, we can close these windows. So now that we've placed all the landmarks, I'll be checking the number of annotations. So we can see here that all of the annotations have been correctly transferred to the optical slide. We can see, yeah, so all of the yellow boxes have been transferred to the correct positions on the optical slide. And notice that we only have 4 patients here and we have 5 annotations, and that's because we're not interested in the tonsil annotation down here. So what we have to do is to delete these dots. And once we're happy with the number of the annotations, we can now click out of this window. Now we can check the number of FOVs. We do that by clicking on this file, on this button, and we can see that this annotation, to scan this annotation, we need 9 FOVs. To scan this one, we need 12 FOVs. And to scan this one, we need 6. And to scan this one, we need 2. So each dot represents an FOV. Once we're all happy with the number of FOVs, we can click out and click the Save JSON. And this is just telling us that the JSON file has been saved. So if we go to the output, we can then check that the JSON file is all good. Yes, this JSON file will be fed into the MIBIscope to complete the scan. If you've missed any of the information, there is a Github Wiki page which outlines all of the steps that I've just described. So feel free to visit this page. Again, if you have any further questions, you can check out our GitHub repository, or you could give us an email. If you have a question about the code, you can email me. And if you have any questions about the project, you can contact ML or Claire. Yeah, so thank you a lot for listening to our presentation. Thanks a lot to the Labat lab, everyone mentioned here, and also Nina, who worked a lot in helping me develop this GUI, and Christian as well, who helped a lot in developing this GUI.
Thank you, Kenta, and thank you, everyone. Don't hesitate to reach out to us if you have any question.
Okay, so unfortunately, the WEHI group could not be here since it is 3 a.m. right now. But if you have any questions, comments for them, I've left their contact info up on the screen here. We are now going to take, so thank you for that great presentation.